ultimately I'll take it common now and I'll cancel it, isn't it? Okay. Okay, next. Cos A plus B. Tell me what is cos A plus B. Same you
Cos A
can
cos B
find a
plus
formula for sin A
cos A
minus
cos
B.
B
And
minus sin A sin B.
cos A cos B
Minus
minus
sin
or
A
plus?
sin B.
minus sin A
Minus
sin B.
sin A
Minus.
sin B. Okay. Now we want to convert this into hyperbolic. Okay. So what is the coefficient of cos hyperbolic? 1, isn't it?
1.
Cos
Then
hyperbolic.
cos hyperbolic of A coefficient is 1. Cos hyperbolic
Cos
of B
hyperbolic.
coefficient is 1 minus
Minus I
sine.
sin
I sin hyperbolic.
I sine hyperbolic of B. Here also
I sin
I
I
hyperbolic.
sin.
sine hyperbolic of B. So cos hyperbolic of A plus B will be cos hyperbolic of A cos hyperbolic of B. I into I will be I square and I square is minus 1. So this will
Minus plus
become
plus.
plus. Hope you are getting it.
Yes, sir.
Third. So what about tan A plus B?
A minus B upon
Tan
1.
A plus B upon 1
Tan A
minus
plus
tan A.
Tan A plus tan B divided by
1 minus tan A
1
tan B.
minus tan A tan B.
tan A tan B. Okay. So we want to convert this into hyperbolic. Yes. What is the coefficient of tan? I
I tan.
tan A plus B.
I tan hyperbolic A plus B.
Yes. I tan, it should be hyperbolic.
Hyperbolic A.
I tan hyperbolic of A plus I tan hyperbolic of B divided by 1 minus I tan hyperbolic of A into I tan hyperbolic of B. Right. So we can take I common from here and that can be cancelled with this I. Right.
Yes, sir.
And ultimately we'll have tan hyperbolic of A plus B equal to tan hyperbolic of A plus tan hyperbolic of B divided by 1 minus, now this I and this I square is minus 1, so plus
Plus.
tan hyperbolic of A plus tan hyperbolic of B. Hope you are getting this. Now double angle for me. Now I'll try to write them directly. Sine 2 theta. What is sine 2 theta?
2 sin theta.
2 sine theta cos theta and 2 tan theta divided by
1 minus
1
tan equation.
minus or plus.
Minus minus.
Oh,
Minus or plus.
Sir, minus.
I think so. Plus plus.
Hey, plus
Plus,
re.
plus,
Plus sir.
Sine square theta plus
plus,
cos square theta 1. That
Plus.
formula is used now.
plus,
Okay.
Yes.
Now we want to
plus.
convert this into hyperbolic. We don't want to write the middle step. We want to write the hyperbolic formulas directly. Okay. So tell me what will be coefficient of sine I. Say I am able to cancel the I. How we'll understand? Sine hyperbolic 2 theta. Okay. So 2, what will be coefficient of sine hyperbolic I? And this I
I
that
sin
is cancelled.
hyperbolic.
Hope you are getting it.
Yes.
Yes,
Now
sir.
what is coefficient of cos hyperbolic of theta? 1. So no need to write
1.
anything.
1.
Okay.
1.
Equal to. Here's first year. Just 1 minute. Okay. So 2 coefficient of tan will be I. That is again cancelled, right? Tan hyperbolic of theta divided by 1. And again the denominator tan coefficient is I, but tan square, then I square. I square is minus 1.
1 minus tan square theta.
Very good.
Tan.
So in this way we can develop the remaining formulas. Getting everyone? Not required, huh? So those who are interested, they can go through the remaining part. Else you can leave it. There is no any problem, huh? So before I proceed, let me write the derivative. Okay, so see, d by dx of sine hyperbolic of x. Hope you remember these two formulas.
Yes.
Sine hyperbolic of x, e raised to x minus e raised to minus x divided by
Minus x by
2.
2.
Okay. What about
I
cos hyperbolic of x? E
E
raised to
raised to
x
minus
plus
x
e raised
minus.
to minus x divided by 2. Huh? We remember these two formulas. We studied them yesterday. So equal to, let me change the ink. D by dx of, since we know the exponential form, let me use the exponential form. E raised to x minus e raised to minus x divided by 2. So see how the derivative is. So derivative of e raised to x is e raised to x, minus of derivative of e raised to minus x is minus it will become plus divided by 2. And this is the formula of cos hyperbolic of x. Right? So
yes.
what is derivative of sine hyperbolic of x? Cos
Cos
hyperbolic of
hyperbolic of
x. Okay. You try it for the cos hyperbolic of x. Try it for the cos hyperbolic of x. See what you are getting.
Sine hyperbolic x.
Minus sin I.
Minus sin hyperbolic.
No, not minus. Only sine hyperbolic
x
x.
minus. Sir, sine hyperbolic of x. Answer.
Only sine hyperbolic x.
Yes, yes.
Have you obtained derivative of cos hyperbolic?
Yes, sir.
Sine
Yes.
Yes,
hyperbolic.
sir. Sin
Sine
hyperbolic.
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 So see,
Hyperbolic.
so d dx of cos hyperbolic of x is plus sine hyperbolic of x. Huh?
Yes, sir. Yes, sir.
Yes,
Right.
yes.
So in case of circular function, the derivative of sine x is cos x, but whereas derivative of cos x is
Minus
minus of
sine.
sin
Minus
x.
sine x.
Right. And therefore, if you might remember, see, while writing the expansion of e raised to x, sorry, expansion of sine x, we have written like this. Let me change the page. Expansion of sine x, it was written like this. Circular function I am saying, ax minus x cube divided by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. Whereas, if you want to write the exponential of sine hyperbolic of x, it is, since all the derivatives are positive, all the terms are positive, very simple, right? The reason is like this, x raised to 7 by 7 factorial and so on. Same is true for the cos hyperbolic of x also. In case of cos x, right, in case of circular function, alternative derivatives are positive, negative. Right? Derivative of sin x is cos x, but derivative of cos x is minus sin x. Right? Whereas in case of cos hyperbolic of x, hyperbolic function I want to say, all the derivatives are positive. Therefore, all the terms are positive only. Okay? Next term is also positive. And so on. And therefore, derivatives are like this. There is change in case of tan x and expansion of tan hyperbolic of x. So, right. So tan x and tan hyperbolic of x. So that you can understand from the properties of derivatives of the hyperbolic function. Okay, this is all about the hyperbolic function. Now let me start with the next part. So usually in our case, in case of exam point of view, I am saying, no example will be asked on the hyperbolic function since it is not in our syllabus. Okay, so we'll start with the next part, Taylor's theorem. So already we studied Maclaurin's theorem. Now next part is Taylor's theorem. Write the statement of Taylor's theorem. Let f of a plus h be a function of h. So a is constant. You can write a is behaving like a constant, which can be expanded in ascending powers of h, and the expansion is differentiable term by term. Then now first understand and then we'll write. See towards screen and understand. See, I want to write expansion of f of a plus h in powers of h. Right? Hope you remember what we have written in case of Maclaurin's theorem. That also I will write for our reference. So in case of Maclaurin's theorem, we had written this. I am writing it here. F of x we have written. How it was written? Expansion in powers of x. So it was written like this: x,
f0 plus
F0
x f dash
then
0.
x square
x
divided
square
by
by
2 factorial. Just 1 minute. You remember in this way: x cube divided by 3 factorial, and so on. These are the variables. Now we have to decide coefficients. We have to decide the constants. And what were the constants? Constants, they were like this. Okay. We have written f of 0 here. Okay. Here we have written f dash of 0. Here we have written f double dash of 0, f triple dash of 0, and so on. Right. Hope everyone remember this. Same thing I am doing here. But here we want expansion in powers of h. Okay. So it is like this: h raised to 0, then h, then h square divided by 2 factorial. Okay, next is h cube divided by 3 factorial, right, and so on. Now we want to decide the coefficients, right? In previous case, in case of Maclaurin's theorem, we had f of x only, but here we have a as the constant, and therefore the expansion is like this. It will be like this: f of a, okay, then f dash of a. This is a, huh? It is not 0. Here it is f double dash of a, then f triple dash of a, and now so on. Getting everyone? Understood? Write it.
Yes,
Sir,
sir.
it means that when a is equal to 0, it will become Maclaurin's
Ha,
theorem.
absolutely. Very good, very good. That is I am writing on the next page. You should be able to understand it in this way. So whenever a is equal to 0, we get the Maclaurin's theorem.
A is constant, no?
A is constant. So it may be 0
So
also, no?
derivative of constant is zero, no?
Huh?
Derivative of constant is zero, no?
No. Acha, that you want to say. It is like this, na? Say f double dash of a. It means that we want to find f of x or f of h, whatever it is, two derivatives, and then we have to substitute x equal to a. Meaning is like this, na?
Okay.
First derivative, and then we have to substitute the value. Okay, we have to write deduction from the Taylor's theorem. Right. Write this as equation number 1. 1. Put h equal to x in 1. So f of x plus a or a plus x. So it will be f of a plus h is x, f dash of a plus x square divided by 2 factorial, f double dash of a, and so on. So we can get expansion in powers of x. This is expansion of f of x plus a in powers of x, or expansion around. Remember this. Sorry, not this part. It is for the next part. Expansion in powers of x. You write this part. This is wrong. Next item. Second, replace a by x. And we'll understand what is the use of all these things. So f of x plus a equal to f of a, that is f of x, plus h, f dash of x, plus h square divided by 2 factor, f double dash of.
So there should be h.
2 मिनिटं, कारण एक हे द्यायचं आहे, मग त्यानंतर एक्झाम्पल देतो ना. हो. This is expansion of f of x plus a in powers of h. What is the difference of this? We'll understand it in case of example. Time being, let me continue. Then write
Sir,
uh-huh.
sir, why you have written that h f dash of x? Not understood.
So you want to say that key here we have written the expansion in powers of x. Here we have written expansion in powers of h. Why it is done like this? That you want to say, na?
Yes, sir.
So that we'll understand when we'll go through the example. Okay. Time being, let me continue.
Okay, sir.
Okay. Then next. So now see what we have to do. Hello. In one above statement, not in one. I'll say this as 2. This is 2. Say this is 3. In 2, put x equal to x minus a. So f of x minus a plus a, that is f of x equal to f of a plus x minus a f dash of a plus x minus a square divided by 2 factorial f double dash of a, and so on. Okay, this is the expansion of f of x, Right. Expansion of f of x in powers of x minus a, or expansion around x equal to a. I will come within 2 minutes. Give me 2 minutes. Till that time you can have tea. start with the next part. Hope I'm audible to you. So we'll go through examples now. Huh? So you might have, I'm audible?
Yes, sir.
Huh.
Yes, sir.
So in deduction, see first equation number 2, here we have written the expansion of f of x plus a in the powers of x. Here we have written the expansion of f of x plus a in powers of h. Here we have written the expansion of f of x in powers of x minus a square, and so on. Okay, so we'll continue. I think it is 23. Examples, madam. Expand expand tan inverse x in powers of x minus 1. Okay, so given f of x equal to tan inverse x. Okay, and we want expansion in powers of x minus a. So by Taylor's theorem, what we can write by Taylor's theorem? F of x equal to f of a plus x minus a f dash of a plus x minus a square divided by 2 factorial f double dash of a. Let's write this. This is what we have written the last statement, right now. So now write, this is expansion in powers of what? X minus a. But what we want expansion in powers of x minus 1, right now. So just compare them. Compare these two. So x minus a equal to x minus 1. So what is conclusion? A equal to 1. Substitute a equal to 1 in above equation. So f of x equal to f of 1 plus x minus 1 f dash of 1 plus x minus 1 square divided by 2 factorial f double dash of 1, and so on. So to complete the example, what is required to us? We want to find this f of 1, f dash of 1, and f double dash of 1. Okay, so I'll write it here. Hope this is clear to you.
Yes, sir.
Yes, sir.
Okay, now here f of x equal to tan inverse x. Find f dash of x. 1 upon 1 plus x square. We know the derivative of tan inverse x. Okay.
Yes,
Then hope you remember this formula. If you don't remember, just try to write it and remember it using. Tell me what is derivative of 1 upon f of x.
Minus 1 upon x
Very
square.
good, very good. Minus f dash of x divided by f of x whole square. Right? Whenever numerator is constant, then this formula is used. So here numerator is 1, which is a constant. Therefore, I am using this formula. So f double dash of x. Let me write the f double dash of x. F double dash of x equal to minus sign derivative of the denominator. So derivative of 1 plus x square, 2x, divided by 1 plus x square whole square. Okay. Now in front of this, we have to write their values. So f of 1. What is f of 1? Tan inverse 1. And what is tan inverse 1? Pi by 4. Very good. Then here you write f dash of 1. So substitute x equal to 1. So 1 upon 1, 1 square. So it is 1 upon 2. Okay. And here we have to write f double dash of 1. So minus 2 divided by 1 plus 1 whole square. So minus 1 upon 2. Right. So we have to substitute these values in 1. That's it. Substituting values in 1. So f of x equal to f of 1 is known to us pi by 4 plus x minus 1 f dash of 1, that is 1 upon 2, plus x minus 1 square divided by 2 factorial is 2 into f double dash of 1, so minus 1 upon 2, and so on. Therefore the answer is like this, that is tan inverse x equal to pi by 4 plus 1 upon 2 x minus 1 minus 1 upon 4 x minus 1 square, and if required we can obtain the remaining terms also. This is required expansion. Understood? Have you understood this?
Yes, sir.
Yes.
Okay, great. Chalo, next example. So Taylor's theorem can be used to find this type of expansion. Sometime, usually it is so in mechanical and civil engineering that it is required to find the expansion about x equal to a, x equal to b, like this. So let me change the page. 24. Expand two x cube plus 3x square minus 8x plus 7 around x equal to 2. Around x equal to 2. Okay, so given, start with me, f of x equal to 2x cube plus 3x square minus 8x plus 7. Okay, now write, according to Taylor's theorem, f of x equal to f of a, x minus a, f dash of a, x minus a square divided by 2 factorial f double dash of a. And since we have x cube, so third derivative is required. Fourth derivative will be 0. So 3 derivatives are required.
Yes, sir.
Right. Right. This is expansion around what? X equal to a, and we want to find expansion around x equal to 2. So what is conclusion? Value of a is obtained now. A equal to 2. Right? Finding this a is very important. Many times students make mistake while finding this a. They, instead of writing x equal to a equal to plus 2, they write a equal to minus 2. So you'll get a wrong answer, and you can cross check it. Substitute a in above relation and you will get whether it is expansion around x equal to 2 or x equal to minus 2. So f of 2 plus x minus 2 f dash of 2 plus x minus 2 square divided by 2 factorial f double dash of 2 plus x minus 2 cube divided by 3 factorial f triple dash of 2 and so on. This is 1. Okay, f of x is known to us, so we'll use that. Alright, since f of x equal to 2x cube plus 3x square minus 8x plus 7. Okay, find f dash of x 6x square plus 6x minus 8. F double dash of x 12x plus 6 is 12. Okay, but you might have understood our aim is to find this f of 2, f dash of
So
2,
F double dash of 2.
yes, and so on. So try to find them. So it is like this. So f of 2, substitute x equal to 2. So 8, 16, 12 minus 16
19.
plus 7,
19.
19. Absolutely. Substitute f dash of 2. So 24 plus
26.
12, 28.
Yes, 28.
Yes, sir.
Yes, sir.
28.
Yes, sir.
Then f double dash of 2.
30.
30.
Absolutely. And f triple dash of 2. 12. If we try to find the next value, it is 0. That is, we can terminate the expansion. Huh? So, right from equation 1, substitute the values in equation number 1 and you will get the required answer. So, f of x equal to, so f of 2, that is 19, plus x minus 2 into f dash, that is 28, plus x minus 2 square divided by 2 factorial, 2 factorial is 2, then 30, plus x minus 2 cube divided by 3 factorial, that is 6, and then 12. Hope everyone is getting this. And therefore, the required expansion is 19 plus 28 x minus 2 plus 15 x minus 2 square plus 2 x minus 2 cube. This is the answer. Getting everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Sure. Next, go to the next example and we'll understand how we can use the Taylor's theorem. So question is like this, using Taylor's theorem. Let me change the page. Right. Using Taylor's theorem, express in powers of x. Okay, so given 7 x plus 2 3 x plus 2 cube, x plus 2 raised to 4. So can anyone tell me what is given? Function of what? F of what I have to write? F of x
X
plus 2. X
plus
plus 2
2.
is repeated. Na? X plus 2 raised to 1, x plus 2 raised to cube, x plus 2 raised to 4. Okay, there. So we have given f of x plus h like this. Right. So by, I'm leaving some space here. By Taylor's theorem. Okay, I can write f of x plus h. And we want expansion in powers of x. So like this, x. Okay, next I write x squared divided by 2 factorial plus x cubed divided by 3 factorial x raised to 4 by 4 factorial like this and dot dot dot. Okay, now I want to write the remaining terms. So what I have to write? F of, yes, anyone? F of h is remaining, na? So f of h, f dash of h, f double dash of h, f triple dash of h, and then fourth derivative 1, 2, 3, 4 of h. So f of h is required. So here x plus 2 is to be replaced by h. Do it. Hope everyone is getting this. I replaced x plus 2 by h. And how it is decided? From the Taylor's theorem. Now I'll compare this. Okay, I'm writing here. Comparing f of x plus h and f of x plus 2. From where I got this? From here, see. Here and here. This is given to us and this is from the Taylor's theorem. So what is conclusion? H is known to us. H equal to 2. That I am substituting here. चेपते सर्वांना हे सबको समझ में आ रहा है क्या क्या मैं कर रहा हूँ?
हाँ सर.
हाँ सर.
Yes, sir.
So f of x plus 2, that is what we have given, na? Right?
Yes,
That
sir.
is
Yes,
equal
sir.
to f of 2 plus x, f dash of 2 plus x square divided by 2 factorial, f double dash of 2 plus x cube divided by 3 factorial. So derivative at 2, x raised to 4 by 4 factorial, fourth derivative. You can write in this way also, at 2 and dot dot dot. Write this as equation number 1. Okay, now I write in this way. Since f of h equal to, write the f of h now, 7 plus h plus 3h cube plus h raised to 4. I am making two parts. Huh? Then f dash of h. Find derivative 4h cube plus 9h square plus 1. F double dash of h. 12h square plus 18h. F triple dash. 24h plus 18. F fourth derivative. 24. Okay. And if you try to find the next derivative, it will be 0. So now we want to find, aim is to find f of 2, f dash of 2 and so on. So f of 7 plus 2 plus, please do it yourself. How much is this?
39.
49.
F dash of 2, F double dash of 2, F triple dash of 2, F fourth derivative at 2. $84. What about this value?
Sir, first is
Sir, it's
49.
69.
69.
69.
Sir, sir, F dash of
First,
2 is 69.
First is 69.
first is
F dash of
49.
2.
F dash is 69. Okay.
First is 49.
49.
49. Achha, that you want to say. Okay. 49, 69, 84, 66, 24. Are they like this? Check it.
Yes, sir.
Yes, sir.
Okay, great. Next. Let me complete it here only. Lecture. उद्या सकाळी ठीक उद्या सकाळी लेक्चर आहे right. Substituting values in 1. Substitute the values in 1. So f of x plus 2 equal to, let me substitute them. So f of 2, here it is 49, plus x f dash of 2 69, plus x square divided by 2 factorial, that is 2 84, plus x cube divided by 3 factorial, that is 6 66, plus x raised to 4 by 4 factorial 24. What about the next term? 0, huh? No
Yes, sir.
need to write dot dot dot. You have to write 0. And therefore, final answer is the f of x plus 2 is written as 49 plus 69x plus 42x square after simplification plus 11x cube plus x raised to 4. So this is the application of Taylor's. Last term is x raised to 4. Hope this is clear.
Yes, sir.
Yes, sir.
Great.
Yes, sir.
Okay. Sure. Next example. Okay.
सर लास्ट टर्म का है
X
X
raised to
raised to
4.
4. Okay. So write down. Use Taylor's theorem. Page I have to change. So you might have understood applications of different terms.
Yes, sir.
26. Use Taylor's theorem to find one minute. 25.15. Okay, so first we have to define a function. Okay, so let so what is x here? 25, whose root is known to us. And h is 0.15. Okay, now I have two different terms that I can use. So let me write them and let me ask you a question. Give me 1 minute. Let me write them. So by Taylor's theorem, if I have f of x plus h, I can write in this way. I can write like this. Say ascending powers of x. So x square by 2 factorial and so on. And then we have f of h, f dash of h here, f double dash of h here. This is one option. Another option with us is, so I can do it in this way, f of x plus h, and I can write it in ascending powers of h. So h square divided by 2 factorial and so on. And in this case, the coefficients will be f of x, f dash of x, f double dash of x, and so on. So already we decided what the x and what the h is. And our aim is to get approximate answer, accurate answer, no doubt, but at least the answer which is near to the exact answer. So more and more approximate answer we want. So can anyone tell me with the explanation why statement number 1 is to be used or second is to be used? See, very simple. Just you concentrate on the different powers of x square, and here h square, and understand it. You will get the required answer. See, what is x here? 25. Right? What will be 25 square? 625 divided by 2, na? Next will be 25 cube. That will be a very big number. Say 12,200. I don't know what it is. 12,200. Say 25. 1200 225 like this, and divided by 3 factorial, that is 6. So numbers are increasing, isn't it? Getting everyone? Okay. Whereas if I consider the next statement, what the h is 0.15. Right now, what will be h square?
Numbers are
15 square,
decreasing.
that is 0.0225. Na? Correct? Na?
Yes, sir. Numbers are decreasing.
225. Numbers are decreasing. 0.00, that is maybe if you take h raised to 4, maybe like this 0.00025 like this. For example, I am saying, right now. So that is after a particular power of the h, maybe h raised to 4, it is not required to consider the remaining terms. काय म्हणते समजते? क्या मैं बोल रहा हूँ समझ में आ रहा है आपको?
Yes,
Yes,
sir.
sir.
Yes, sir.
See, h is 0.15. If you take h square, it becomes 0.02. It may be that h raised to 4 is like this 0.000 and 225. Okay. So it means that if we consider first 4 terms only, that will be sufficient. We will get more approximate answer, which is not so in case of above case. We cannot terminate the expansion anywhere in the above case. Since the numbers are increasing, x square is increasing, x cube will be greater than x square, x raised to 5 will be again greater than x cube, and so on. Getting everyone?
Yes, sir.
Everyone, at least I think only 2-3 people are speaking. What about remaining? Are you getting this statement?
Yes,
What
sir.
I am
Yes,
saying,
sir.
getting?
Yes, sir.
Yes,
Therefore,
Yes, sir.
Yes, sir.
we have to use this.
Yes. Yes, sir.
So I'll leave this part now. We understood the concept now. Okay. I'll start with the Taylor's theorem once again. Okay. So you can leave this part. So by Taylor's theorem, f of x plus h equal to f of x plus h f dash of x plus h square divided by 2 factorial f double dash of x. At least we'll find up to h cube and so on. Right. Since h equal to 0.15, x equal to 25. Substitute the values. Both the values are known to us. Substitute them. So f of x plus h equal to f of x 25 f dash of 25 0.15 square divided by 2 factorial f double dash of 25 plus 0.15 cube divided by 3 factorial f triple dash of 24 and so on. Question number 1. Okay. Then write since f of x plus h equal to square root of x plus h. So what will be f of x? We have to replace x plus h by x. Root of x. What will be f dash? 1 upon 2 root x. What will be f double dash of x? So x raised to minus half. Right now derivative I think anyone know. So x raised to minus half. So minus 1 upon 4 and x raised to minus 3 by 2. F triple dash. So x raised to 3 by 2 minus 3 by 2. So minus minus it will be plus. Minus sign over. X raised to minus 3 by 2. Getting everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then now we have to substitute x equal to 25. F of 25. Square root of 25. 5. F dash of 25.
1/10.
Yes. So 0.1.
Yes, sir.
Okay. Then F double dash of 25. You can use Kelsey for this. So square root is 5. Then 125. 125 into 4 minus 1 upon 500.
Yes,
Check
sir.
this. So minus of 0.002. Check it, huh? Please check it. Use Kelsey and check these values. And then this is F. How much is this?
3 by 25,000.
0.0012.
2, na?
Yes, sir.
Okay. Now, done. Substituting all these values in equation number 1, I have to change the page. And then I think we'll stop after this example. And this is all about the expansion of function. Tomorrow we'll go through the next part. Can I change the page?
Yes, sir.
Yes, sir.
Let me write it once again. You can skip this part. Okay, you write the values. So it is like this. F of 25 is 5. F dash is 0.1. Then this is minus of 0.002 divided by 2 factorial is 2. I think I have made the mistake.
Yes, sir. Numerator will come 0.15 square.
Sorry. You leave this part. Okay. Better I'll write it once again. Three factorial is 6. Yes, find the answer. See whether your answer is like this.
Yes, sir.
Yes, we'll stop here. Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. Chalo, bye bye.
Bye, sir. Thank you.
Okay.
Bye, sir. Thank you, sir.
Bye. Thank you.
Sir, attendance.